Okay, so find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. Okay, so let's graph y equals x squared. A y-intercept at 0, 0, and a pattern of over 1, up 1. Keep it symmetrical. Over 1, up 1, 2, 3. And over 1, up 5. And here is our parabola, y equals x squared. Okay, so here's the goal. Finding an equation. That is, we're going to end up writing this as y equals m, x minus x naught plus y naught at the point 1, 1. So I'm looking to find the equation of this tangent line to this curve at this point. Okay. So if I just do a quick sketch of the tangent line, and it looks kind of like this. And my job is to find the equation of that line. Okay, so finding the equation of a line, I've been given 2 points on the line. Those 2 points, or sorry, I've been given 1 point on the line. That point is this point right here. Here is your x naught, y naught. So right now I could start answering the question. Y equals m, x minus 1 plus 1. The thing I don't know is what's the slope of that line. So the way I find the slope of the tangent line, the solution is, instead I'm going to find the slope of the secant line through some point PQ. So that means I'm going to take a y2 minus a y1 all over x2 minus x1. Okay, where my x1 is the point that I've been given. So the slope of a secant line is going to be the function at x2 minus 1 over x2 minus 1. And what is the function? Well, the function is y squared. So whatever x value I put in here, the y value is going to be this x value squared. So this becomes x squared minus 1 over x minus 1. So for any point I choose on this graph, like if I choose a q value up here, then that point is going to be, looks like x is 2, y is 4. So then the slope of this line that goes through these 2 points, the slope of the secant line, would be 2 squared minus 1 over 2 minus 1. And the slope of the secant line would equal 4 minus 1, which is 3, over 2 minus 1, which is 1. My slope would be 3. And you'd say to me, well, that's not really that good of a job, because this slope isn't really that close to this slope, is it? So tell me to do a better job. So let's do a better job. Then we're going to choose another x value that's closer. So if I chose x to be 2, the slope of my secant line was 3. If I choose something closer to 1, how about I choose 1.5? So then the slope through those 2 points is going to be, once again, f at x2 minus 1 over x minus 1. What x value did I choose? I chose 1.5. So I've got 1.5 squared minus 1 over 1.5 minus 1. And you can grab your calculator and tell me what you get. But what did you get here on the top? Okay, so that's a better approximation, but that's still not really that good. So I let x equal 1.5. How about if I get closer still? What about if I let x equal 1.1? Then can you find the slope of the secant line through the point 1, and the point 1.1 and the function at 1.1? So 1.1 and the function at 1.1. Sorry, 1.1 here, the function at 1.1 there. Okay, so go ahead and try and do that. I got a shortcut for you, but I have to know you understand this first. Okay, I got it from here. Did you understand this step here? Did you understand this? Okay, so finding the slope of the line, y2 minus y1 over x2 minus x1. We're good with this, even this f notation. Okay, so then if I'm looking at what is my x1, it's this point right here. Okay, so if x is 1, then y is 1. That's where those two came from. If x is any other number, then y is the function at that number. What is the function? Whatever you put in, you get squared. So I'm going to say, I'm not going to call it x2 because it's just awkward and I only have one of them in my equation. So I'm just calling it x. And then the y value would be the function at x. What's the function at x? X squared. Okay? It's a good question because it's all those little details that you need to, there's so much going on here. Okay, do you guys all have the answer for 1.1? Are you getting 2.1? Okay. Okay, but it's still not close enough. Why don't you try 1.01? Are you getting the answer 2.01? Okay, and now are you tired of doing this slope here? Let's program your calculator to do it for you. Okay, so in your equation editor, would you please program what you're doing? Every time you're taking bracket x squared minus 1 bracket divided by bracket x minus 1, close the bracket. Every time that's what you're doing, and all you're doing is substituting in a different x value every time. So let's find something closer to 1, like 1.001. So go to your table, and this should be set up, second table set, it should be set up so that it's on ask. So you put in the value, check what we're doing here. If I, if I put in the value of 2, I get 3 for an answer. If I put in the value of 1.5, I get 2.5 for the answer, just checking I've done this right. And 1.1, 1.01. And now the one I want, 1.001. And I'm getting 2.001 for my answer. Okay, so this is what we, yeah? Okay, one more time. How you program it. In your equation editor under y equals, can you see that screen there? Okay, in the equation editor under y equals, program in the equation that you keep on using to find the slope of the secant line, x squared minus 1 over x minus 1. Got it? Okay, so then look back here. What's happening then is a limiting process. So x's are bigger than 1, but do you see that I'm letting my x get closer and closer and closer to the value 1? So x gets closer to 1. What happens to the slope? What's the slope getting closer to? 2. We call this the right-hand limit. So we write it like this. The limit as x approaches 1 with a little plus in the subscript. The limit as x approaches 1 for the slope of the secant line. What's that limit? It's equal to 2. The right-hand limit. Okay, but what if approaching it from a point over here on the left doesn't give us the same slope? Well, then we're going to use the left-hand limit. So we're going to approach 1, but we're going to approach it from here. Like, let's start at x equals 0, and then get closer, x equals 0.5, and get closer, x equals 0.9, get closer, x equals 0.99. Or 0.999, find the slope of the secant line. If you've already programmed this into your equation editor, then you've got an easy task. Just go to your table and start putting in the values. 0. What's the slope of the secant line? 0.5, 0.9, 0.99, 0.999. And as we approach the value of 1 from the left, you can see the x is getting closer to 1. The slope of the secant line is getting closer and closer to 2. I'll answer